Hello, this is my Module 11 discussion post for this week. And the question that we are looking at is how well can we predict a student's score on the final exam based on their performance in the class from the first 13 weeks of the semester? So the two variables, or the two explanatory variables I will be looking at are the results from exam 1 through 3 and then the quiz results from 1 through 10. And then the response variable for both of those is going to be exam 4. So the first thing I will go through are the three histograms that I created. So the first one is, include the results from quiz 1 through 10. So the mean was 74 for the quiz, and then the standard deviation was 13.52. And as you can see, the shape is pretty bell-shaped curve, I would say. It has a tiny bit of skewness to the left, but nothing major. And then for the second histogram, which includes exam 1 through 3, I would say it's pretty symmetric. It's a normal distribution. And then for the exam 4 histogram, I would say it's unimodal since this one seems to be the tallest. However, I forgot to mention, for exam 1 through 3, the mean is 71, and then the standard deviation is 15.26. And then for exam 4, I wasn't sure if we needed to make a histogram, but I did just in case. And then I got the mean as 63 and then standard deviation as 17.07. So again, I would say this is pretty unimodal. And then I will go to my scatter plot. So on the y-axis is the exam 4 for both of them, and then, or the response variable, and then the x-axis is the quiz 1 through 10 and the exam 1 through 3. So we'll go through the quiz compared to exam 4 first. So I added the vertical line since the mean was 74, was 74. And then for the horizontal line for exam 4, I included the horizontal line to represent the y mean, which was 63. I put it down at the bottom. And then I also added the regression line too. And then the correlation coefficient is 0.57. And within the scatter plot, there are a few outliers. The one between 80 and 100 is kind of an outlier over there. And I would say most of these scores were either in quadrant 1 or quadrant 4. So this one will be quadrant 1, 2, 3, and 4. And as you can see, they both kind of gather around the upper part of the regression line in between quadrants 1 and 4. And then over here I have my equation, y equals 0.7173x plus 9.7619, and then r squared is 0.32, or we can look at it as 32%. And this is a percentage that is explained by the regression line, but so it's 32%, but if we do 1 minus 32 or 0.32, that would still be the remainder even after accounting for quiz scores. And then for the slope and intercept and simple linear regression, it's the relationship between two variables, and it can estimate the average rate of change. And then the x right here is the slope, and then that's the value that you would the value that you would use to plug in to get your predicted score. So we can say that 32% of the variability can be accounted for on the quizzes. And then for the exam 1 through 3 and exam 4, my horizontal line includes the mean for 63 for exam 4, and then the mean for 1 through 3 was 71. So they were pretty similar, I would say, between the quiz and exam scores, or their means at least. And then I got a correlation of 0.73 or 73%. And as you can see, for this one, I would say there are a couple outliers, maybe right here, and then up here in the corner as well in quadrant 1. And I would say most of the scores gathered by the regression line more in quadrant 1 and 3. And then for the regression line, or the equation, I got y equals 0.8212x plus 47042, and then r squared is 0.54 or 54%. And again, r squared is just the percentage that is explained by the regression line. And then if you subtract 1 minus 0.54, that would be the remainder, or you'd still have that remaining even after accounting for the exam scores. And then from there, we will go to regression 2. So again, I did quizzes 1 through 10, and then exams 1 through 3. And then I wasn't positive for the regression equation. I kind of just copied it from the page number that she gave us. So I just pretty much added up the intercept, the quiz 1 through 10, and exam 1 through 3 B coefficient. And for that, I got 4.6518. And then for the student that I chose to predict their score was 113. Their ID number was 113. So their average on 1 through 10 was 80. Exam 1 through 3 was 86. Exam 4 was 63. Predicted for exam 4 is 75, and then the residual or difference is negative 12. So that was for the multiple regression results. And then for the single regression results, I got, so again, we're looking at ID of number 113. So their quiz average was 62, and then discussion average was 74, which we're not really looking at discussion, we're just looking at quizzes and exams. And then exam average was 42, and then exam 4 was 54, and then I calculated by putting in 56 in place of x, and then calculating the equation, and I got 50, and then subtracted 56 minus 50 to get the residual or difference. And based on my results, I would say the single regression line would predict their score better, just because we got a difference of 6. And I think it would tend to be true, maybe not always true. I guess it just depends on several circumstances, like how much they studied, or kind of just based on their past exam and quiz and discussion scores as well. But yeah, that's it. Thanks.